Here is an AP style free response question. For this one, a calculator would be permitted. The function f is defined as f of x is equal to 4 times e raised to the 3x squared. Find f prime of x. Then, for what value of x is the slope of the tangent line to the graph of f equal to 3? And then for what value or values of x does the tangent line to the graph of f intersect the x-axis at the point 1/2, 0? Let's begin by finding f prime of x. Some may want to use what's called U-Substitution in order to differentiate this a little bit easier. If we were to use U-Substitution, we could set u to be the exponent of e. So that would be 3x squared. And then if we differentiate u with respect to x, it becomes 6x using the power rule. So what we can do is we can rewrite f of x in terms of u. So f in terms of u is equal to 4 times e to the u. Well, if we differentiate, f prime of u would be 4 e to the u times du over dx. And then if we substitute the u and the du dx back in, we will end up getting 4 e to the 3x squared times 6x. And then if we multiply 4 times 6x, we end up getting 24x times e to the 3x squared. Now let's try part B. For what value of x is the slope of the tangent line to the graph of f equal to 3? Well, the slope of the tangent line refers to the derivative evaluated at a specific x point. So we need to first find the derivative of f of x, and we've done that. It is 24x times e to the 3x squared. And then if we were to set the derivative equal to 3 and solve for x, we will end up getting that value. And you can do that graphically by graphing them both in a coordinate plane and finding that point of intersection. And we're using that because the use of a calculator is permitted. And it's a little bit faster to do it this way. So graph both the line y equals 3 and y equals 24x times e to the 3x squared and see where the two of them intersect. And they intersect at the x value of 1,197/10,000ths. And now for part C. For what value or values of x does the tangent line to the graph of f intersect the x-axis at the point 1/2, 0? Well, let's first start with the general point-slope form to represent the equation of our tangent line or lines that will intersect through 1/2, 0. So that would be y, which is now f of x, minus the y-coordinate of our point 0, is equal to m times the quantity x minus the x-coordinate 1/2. Now from here, we know that the slope is going to be the value of our derivative. So that's going to be 24x times e to the 3x squared. We're going to fill that in for m. And we can fill in 4 e to the 3x squared in for f of x. And when we do that, our equation will look like this. And once we have our equation in point slope, we can distribute the 24x e to the 3x squared through to both terms on the right, and move the 4e to the 3x squared term over to the right as well with subtraction. That'll leave 0 being equal to 24x squared e to the 3x squared minus 12x e to the 3x squared from distribution, and then minus 4e to the 3x squared when we move that over. And that is equal to 0, which is neither positive nor negative. Once we have this, we can solve this equation by finding the x-intercepts of this new function that we have. So when we graph it and look for our x-intercepts, they represent the solutions to this problem. And those x values are 729 thousandths and negative 229 thousandths.